Hi everyone. In Chapter 3, we compared categorical variables by examining contingency tables. But in Chapter 4, we're going to compare quantitative variables, and we're going to specifically look at box plots. I want to start, though, by just looking at a data set that I'm going to use throughout the videos for this chapter. So this is a data for the percent change in population for all 50 states based on census figures for the year 2000 and 2010. And as you can see, my table doesn't show all 50 states. It wouldn't fit on the slide, but I cropped it so you could at least see a snippet of the data set. So it shows three variables. We have state, which is a categorical variable, but in this case it's an identifier variable too. There's only one state in each category, so it's not really much to look at. Then we have percent change in the population, and this would be a quantitative variable. And then this table has split up the United States into two regions, a Northeast Midwest region and a Southwest region. And so this has created a categorical variable. Now, if we were in a face-to-face discussion, the first thing I would ask you is what type of graph is on the right and why? How do you know it's that type of graph? So what I have here on the right is a histogram of this data. I know it's a histogram because there's no spaces between the bars and because it's displaying a quantitative variable, percent change. So since it's a histogram, I can describe the shape of this distribution. And if I look at the shape here, I've got, looks like a unimodal distribution skewed to the right, and it looks like we might have an outlier over here. I'm not quite sure. Because it's skewed and because of this possible outlier, the median would be the best measure for the center, and the IQR the best measure for the spread. So now, what if we wanted to break this, data set into regions and compare the Northeast Midwest region with the Southwest region? So the first thing that I did was I put each region on its own histogram. And comparing these regions, it's actually quite difficult to do by just looking at histograms like this. I mean, they're both unimodal. I can see that outlier over here again. Looks like they're both slightly skewed, but when I look further at that horizontal axis, I can see that the bin width of the Northeast Midwest region is different from the Southwest region. So over here, the bin width is 2.5, right? It's going from 0 to 2.5, 5, 7.5, 10, and 12.5, whereas the bin width for the Southwest region is 5. It's twice as much. This is counting by 5, 10, 15, 20, 25, 30, 35. So the bin width is bigger for the Southwest region, and the values that are shown along the horizontal axis are different as well. For the Northeast Midwest region, it's starting below 0 and going up to 15, whereas for the Southwest region, it's starting at 0 and going up to 40. So this makes it kind of hard to compare. It would be a lot nicer if these were both on the same set of axes, which is something that I can do with a stem and leaf plot. So I created a back-to-back stem and leaf diagram for the two regions. So I've got the Southwest region here and the Northeast Midwest region here. When you're reading this, for the region that's on the right, so for the Southwest region, we read the diagram from right to left. So, for example, if I were to look at this row right here, so this would read 15, 17, 18, 18, and 19. Whereas for the other side, for the Northeast Midwest region, when I read this, I actually have to read backwards. I want to read from right to left. So I'm going to read the 1 and then the 5. So this would be a data value of 15. Right, and like this one would be 12 and 13. So it's a little bit weird reading those backwards, but that's how to read a back-to-back stem and leaf diagram. But what's nice is that I can now look at the shape of the distributions on the same set of axes. So I can now see that if I kind of turn this sideways and I look at this histogram for the Southwest region, it's definitely more spread out than the distribution for the Northeast Midwest region. But it's still kind of hard to look at. And also remember that stem and leaf plots only really work for small amounts of data. So what if this data set had been much larger? I wouldn't be able to do this. So instead, we look at box plots, because box plots allow us to look very nicely at two different distributions on the same set of axes. So these are side-by-side box plots, and I want to first go through and just discuss what a box plot shows, and then we'll talk about actually comparing these two box plots. So I'm going to look at the Southwest region here, and when you're looking at a box plot, the box part is made up of Q1 and Q3. So this value right here is Q1, and this value right here is Q3. And the middle bar here is the median. So that means that this distance, this range right here, is the IQR of the distribution. Because remember that the IQR is Q3 minus Q1, or the distance between Q1 and Q3. Now a box plot splits everything up into quartiles, into 25%. So we would have 25% of the data from here. Now this value right here is the minimum. It's only the minimum because I don't have any lower outliers. So I have between the minimum and Q1 here, I have 25% of the data. Then I have another 25% of the data between Q1 and the median, another 25% between the median and Q3, and then another 25% between Q3 and the maximum. But the maximum happens to be an outlier. So this is an outlier, which also happens to be the max. So even though 25% includes this whisker and the outlier, the box plot's pretty good at showing that most of that 25% is within this whisker here, whereas that outlier is way up above the rest of the data. So then when we're looking at the comparison between the Northeast Midwest region and the Southwest region, we can immediately see right away that this median is below this median by quite a lot, actually. So the median is lower for the Northeast Midwest region. We can also see immediately that the percent population growth for the Southwest region is much more variable, meaning it's more spread out. And that's because the box plot itself is more spread out. Both regions have outliers. So we had this top outlier up here for the Southwest region, and then the Northeast Midwest region shows two outliers, here and here. Now these two outliers, when we were looking at the distribution as a whole, we didn't see these as an outlier because they'd be like part of the middle part of the data for the Southwest region. So when we looked at all 50 states, we did not see these two outliers. We did see this one up here when we were first looking at that first histogram. I also want to just note that I created this on StatCrunch, and when I did this by hand, I only found one outlier, not two. We're going to do this one by hand, so we are going to get a slight discrepancy here. But it's really just the way that StatCrunch calculated Q1 and Q3. And our calculator will do it just slightly differently. And then finally, this northeast Midwest region, we can see that this started below 0, whereas the southwest region, all of the states in the southwest region had a positive percent population growth, whereas there was at least one, and it turns out to be exactly one state in the northeast Midwest region that was below 0, giving a negative percent population growth. All right, so I'm going to end this video now and then make a second video on how to actually create a box plot.